Yes, a very good morning students. Myself Ranjan Chowdhary, PGT Physics teacher, LPM school. Right? So today our discussion will be on the potentiometer. In the previous lecture we have discussed about the meter field and some numericals. Today we will have discussion on potentiometer. So when we study about any instrument, then first we have to know what it is, that is on what principle it works, right? What is the use? Then you have to give the construction, then you have to give the working. First you have to mention the principle, right? Then you have to give the construction, then principle. That is working, right? So see here, first potentiometer, what is work, right? Generally it measures EMF of a cell. So question arises, EMF of a cell can be measured with a voltage, that is voltmeter, right? But it measures EMF of a cell more accurately than voltmeter. Means if you measure EMF with the help of potentiometer, then that measurement will be more accurate than in comparison to measurement done with the voltmeter. But then also, though it measures accurately, but generally we use voltmeter only to measure the voltage. Why? Because it is small in size, right? It is very big in size. So generally we don't use, we prefer what? Voltmeter. But it is more accurate than your voltmeter in terms of measurement. Right? Now let us see principle. It works on the principle that flow of potential across a wire of uniform cross-sectional area through which constant current is flowing is proportional to the length. For example, we have taken a wire of some length. Its area of cross section is uniform, right? And current flowing through the wire is constant. Then it is seen that the potential drop across its length, that is potential drop across its length, will be directly proportional to the length. That is, as the length increases, potential drop will go on increasing. If the length decreases, then potential drop will go on decreasing. Right? This is the principle. Just potential drop across the length is proportional to the length. Condition is that area of the wire must be uniform and also constant current must be flowing through it. Right? Now let us see the construction. Right? Now see, it consists of a wire AB. Here we have given name ABC. The starting point is here. It consists of wire, right, of few meters. Now see, if we take in a straight line, if wire is taken in a straight line, then it will be very, very long. So what we have done, that wire is direction is changed. Means we have taken copper strip and first we have, for example, we have connected 100 meters. Same wire from here to there, we get 100 meter, 100 meter, 100 meter. That is 400 meter. Now see, our size is only this much, right? So it is not 100 meters, right? It is centimeter. Sorry. In this example, we have taken a wire of how much length? 400 centimeter. It can be 600 centimeter. It can be, that is 1000 centimeter, right? But here, length of the wire is more in comparison to meter bridge. In meter bridge, we are using only length of wire 1 meter. Here, for example, we are using 4 meter or 6 meter or 8 meter, right? These are the copper strip just for connection. That is, it consists of wire AB, few meters in length, made of manganese or constant. Wire is not made of copper, it is made of alloy, that is manganese or constant. A jockey, see here, this is jockey, is connected through a galvanometer. When galvanometer is connected, jockey is connected to galvanometer, and the jockey is meant to slide over the length of the wire, right? It is meant to slide over the length of the wire. And there is also a key here, right? A switch, right? So what will happen? Now see, let L is the total length of wire. Here we have taken 400 centimeter. Let us consider it is equal to how much? That is equal to, it is given by L, right? So now we have given voltage that is equal to E, right? When we connect with the K, then current will be flowing, right? Then when current will be flowing through this wire has its own resistance, 10 ohm, 20 ohm, it will have its own resistance. Then along this wire, across this wire, there will be potential drop. Let us consider. Total length of wire is how much? L, and total potential drop, that is from A to B, potential drop is how much? B. So potential drop per unit length, or according to principle of potentiometer, what I shall say? Potential drop across the length of wire is proportional to L, right? Or V equal to KL. When you remove this proportionality sign, then we will introduce a constant, that is V by L is equal to K. That is the potentiometer. The potential drop per unit length of the wire is always constant, and it is known as potential gradient. Potential drop per unit length. It is always constant for a potential. Now see, this is the actual construction of a potentiometer. When you go to the lab and see it, practically it will look like this. But while solving, or when we draw the circuit, or when we show the application of potentiometer, then instead of this total wire, we will just show one wire. That is between A and B, there will be only one wire. But remember that wire will have more length, that is around 400, 500, anything. It will be not having. In meter bridge, we are using one wire. There it was practically also one wire. But here you see number of wire is more. But while drawing the circuit for our convenience, we will use only one wire between A and B. Right? But when in examination question is asked about the potentiometer, then you will draw the actual circuit. Right? So this is the. Now what is the application? For your syllabus point of view, there are two applications mentioned. First, to compare the EMF of two cells, means two cells are given, then we can find out the ratio of their EMF. That is comparison of the EMF of two cells. Secondly, you are given a cell and you can find out its internal resistance with the help of potentiometer. Right? That is application or uses of potentiometer. Yes. Now, uses of potentiometer, that is to compare the EMF of two cells, and second is to find out or to determine the internal resistance of a cell. So, we have drawn the diagram, that is wire is connected between A and B, that is length of wire is very large, but here generally we have shown only that is one wire, that is A and B. Right? Then we are supplying, that is in potentiometer, a battery is connected E through ammeter, resisted resistance R and P. At point terminal A, we are connecting two cells E1 and E2, and there are switches 1, 3 and 2. That is when switch 3 is connected to 1, then cell 1 will be in circuit, and when the switch 3 is connected to terminal 2, then this cell will be in circuit. And this is your galvanometer. And these are the position of your jockey. Right? When cell 1 is connected, then balance point is at J1, and when cell 2 is connected, balance point is at, that is J2. Right? So, how to compare the EMF of two? Now see, in first case we have to close the switch K and then we have to close the switch 1 and 3. Means when you close the switch 1 and 3, then this is in open circuit, it will have no role, it is out of circuit. Now see, current will be flowing, that is through this, that is E1 will be in this circuit, and for this condition balance point is at where? J1. That is, if this is the balance point, then potential across this length is equal to potential of this cell E1. That is, we can say across, that is this potential E1 is proportional to what? Length of this wire. That is, let us consider length of the wire at this position, that is known A2, that is J1. That is how much? L1. Right? So, now see, if it is L1, then we can write E1 proportional to L. That is, it says the principle. What does the principle say? The potential drop is proportional to the length. That is, now in the circuit E1 is there, so it will be directly proportional to the length L1. Right? Okay, so I have redrawn the circuit, that is, it is not out of the, because this is our wire, so this balancing point must be within this wire AB, right? That is our balancing point is now at J1. Second case, if we close switch K and switch to 3, Now see, this is open, this is closed. So in circuit, cell E2 will be in the circuit, and let us say balancing point is at J2. Let its length is L2. So according to principle of potentiometer, E2 proportional to E1. First we got how much? L1. This is equation 1. Equation 2. Now what divided by 2? That is, now you can measure the L1 from here. You can measure the L2 from here. Right? That is, you can know the length. Just putting the value of length, you can find the ratio of the E1 to the E2. That is, we can compare the EMF of right? That is, with help of potentiometer. In this process, we can compare the EMF of right?